Welcome everyone to the latest edition of the AVL Reimagine Mobility podcast series. I'm here with Sean O'Kane and Michael Bambula from AVL. Michael works in our Advanced Simulation Technologies group and Sean works in our Technology Development group. Welcome both guys. Thanks for joining me. Maybe we'll start out with, you guys are both working in the battery space. EVs, I think we can say it's booming. Everybody needs batteries. Everybody needs technology help and technologies as it relates to electrified propulsion systems. And maybe to start out with Sean, to kind of then tee off Michael here. Sean, when it comes to battery development that you've been doing for many, many years, I would assume simulation over the years has become more and more important in your work. But how important really is today's simulation when you compare it to maybe 5 years ago?
Well, even just 5 years ago, it's improved greatly, and one of the benefits that it brings is its ability to maybe even eliminate some testing, some actual physical testing. So you can do in simulation what used to take a lot of physical testing. You'd have to build samples, get them out to test, and then take a look at those results. And apply that to your design. Whereas with the way that the tools are able to do now is in the design phase, be able to accurately predict some of those tests and maybe even some accommodations then that you could make in the design to say fix some flaws or weaknesses.
Michael, maybe the same question to you. 5 years ago, we did simulation tools, or simulation tools existed in batteries. Now we're 5 years later, and certainly batteries even more important than they were 5 years ago. How far along has simulation technology come to keep up with the, let's say, new demand in not necessarily more, but more demand on the tool to do even more work for us to develop this technology even faster and better?
Yeah, I would say 5 years ago, the tools did exist, but within the past 5 years, especially with the changes that we've seen in the mobility industry going towards the alternative propulsion technologies, there's been an increase in development efforts. And, you know, as Sean has said, you know, their story is always that simulation can enhance a test, you know, so instead of doing a deep, really, detailed test matrix, you can test a few points to develop the model and then virtually probe the other areas of the matrix in simulation, which helps gain insights, whether it's worth it to even devote real hard resources on those additional test areas. Mm-hmm. It basically gives you more insight. You're able to see different temperatures across the entire system, which you wouldn't be able to with just pure testing. You'd have to thermocouple different regions. So yeah, overall the space is exciting, a lot of developments.
When we're talking about batteries, and you just highlighted a little bit the temperature measurements, right? Thermal management, one of the key, maybe sometimes a little forgotten to the more general public, but Sean's nodding right away. Thermal management, one of the key challenges. How close, Michael, are we when it comes to correlation between what we actually measure or are able to measure in the battery and what we're simulating? How close is that correlation today? And how far have we come from 5 years ago to kind of highlight maybe how the simulation capabilities have increased, or the modeling accuracy maybe?
Yeah. So I'd say on the thermal management side, it depends on what levels of thermal modeling you're doing. So just on normal battery operation in use, nominal operation, I think we have really close correlation between test to 3D CFD to even system model. We've demonstrated that there's a very strong, tight temperature correlation of a few degrees. I would say this is really important because you can't overcool a battery. With older thermal management methods, you just want to maintain a temperature operating point. But that in a battery electrified powertrain has a trade-off of range. If you're overcooling, you have a diminishing return with respect to range because you're dedicating more power to run the pumps and the auxiliaries. But so that's the interesting challenge, is to understand that, to fine tune that temperature control with respect to not impacting your range. Now, when we go to other deeper, like more, I guess, chaotic temperature operating points, like a thermal runaway, that's an ongoing area of research within the industry. I would say AVL is very strongly positioned with our testing capabilities, our in-house knowledge on the engineering side, and then on the simulation side, to blend all those together and really understand that phenomenon in more depth and model that phenomenon, which is very high value, high risk, even in a testing environment. So we deliver both decreased cost expenditure, cash expenditure for those tests, as well as decreased risk to the personnel who perform these tests.
And Sean, maybe a very similar question along those lines, and feel free to comment on what Michael just said, but for you that is responsible to lead teams in developing of, again, let's say batteries, modules, packs, where is simulation playing maybe a much bigger role or a much more key role versus others? So where do you use simulation more or rely more on simulation, and which ones maybe less?
Well, as Michael pointed out, for the potential of thermal propagation and the mitigation of thermal propagation, it's an amazing tool. You can assume that you have an event in a battery pack. It's going to vent gases, and it's being able to manage when that happens and direct maybe those gases in a particular way, knowing what materials might be in the path of those gases and how combustible they might be, or what they might add to the event. Or you can then figure out how they can not add to the event, right? All in simulation. So being able to safely handle a thermal event, it's an amazing tool. And then that is leading towards eliminating the possibility of a thermal event, and at the cell level, module level, and pack level as well.
Some OEMs and some in the industries have shared that they believe they can get away with physical testing and do everything in the virtual world. Let's take thermal management, for example, right here, because it is, again, a key topic. Sean, do you see that it is actually possible to not test a physical battery specifically for the potential of a thermal runaway event, and do it all in simulation? And if simulation tells us we designed the batteries so well that it's not going to happen, you're good with it? Or are you more like, yes, we can push the boundaries of how much physical testing we need to do, but the physical testing, at least from what you can say, in the near or even long-term future, is not going away? Can you give me a perspective on that?
I would say that in the near term, that the physical testing is still a very useful tool, and in a number of ways. It can tell you exactly what's happening with your design and with your pack, as well as feed data back into the model so that the simulation tools become stronger with that data. And then that, hopefully in the near future, could lead to either less testing or maybe even no testing.
Okay. Michael, what do you see when you talk to customers for some of the tools that you're responsible for? Is their goal to eliminate physical testing? Is their goal to reduce the physical properties you need and the time you need, which is obviously way more expensive than doing it digitally or in simulation? Or what are they mainly looking for in simulation tools? Again, let's stay with batteries here for a moment.
What I would say, at least on the battery, when it comes to the cell side of things, they will likely have to test due to the phenomenon of thermal runaway being pretty, it's understood, but the actual root cause of these events is not always well understood. So they always will have to test the cell for the energy release and how that looks. As far as when we get to the pack and module level, they want to do more of this in simulation, because those events, when you start doing an energy release on an entire pack, is very, very, I'd say, there's only a few testing locations in the world that can do this safely. And as well, you only get one shot. It's a destructive test. So if you have prototype cells, if you have prototype enclosures for the pack, prototype materials, anything like that, those will likely be sacrificed for the test. So they want to be able to reduce as much of that as possible, because that is the definition of a high risk, really expensive test is a prototype destructive test. So yeah, we see strong appetite from our customers within the industry to reduce the amount of those that they perform and perform as much of it in simulation.
And then too, at the end of those tests, sometimes, the evidence literally is not there. It's gone. It's a destructive test. So in simulation, you can go deeper into an event while actually seeing what might be happening. Whereas in a physical test, once the initial event is moved on to, say, it's propagated, more and more evidence is destroyed, and even your instrumentation can be destroyed in that event.
Yeah, very true. When we take a battery for a moment, and let's leave testing out that we just talked about, that we're clearly trying to strive, as Sean, as you mentioned, and Michael as well, to try and eliminate the physical testing and replace it with simulation or digital. When we take simulation tools, how much longer would the design of a battery, again, testing aside, but the design of a battery take today if we had simulation capabilities of what we had, let's say, 5 years ago? How much longer, Michael, would you see, and then we'll ask Sean the same thing, would you see the battery design take? Is it 50% more manpower? Is it 50% longer? Any ideas on that?
Yeah, I would say it's that question of if you, I guess if you devote more resources, does it necessarily speed up the development process? I think through simulation, you're able to really investigate more and more. So if you did it the traditional way, maybe 5-7 years ago, you see definitely a time improvement. I would estimate on the order of 20% or so, maybe even 33%, a third of the time cut by doing a lot of these in virtual. But I think the bigger question is not so much about the time or even the cost, it's what performance is left on the table. And so you see many people would be able to design, to put a battery pack together. Now, is that the most efficient design? Is that the safest design? Is that the one that will yield the most range out of the system? That, I think, is the bigger question, and especially how competitive a lot of these battery electric vehicle companies are to stand out when it comes to EPA range testing and the reassuring the customer of range anxiety, or that the battery will stay within a warranty and they won't have to replace it prematurely. I think that's the bigger benefit that simulation comes to, as well as obviously decreasing development time and saving on the cost of the development.
Okay.
Yeah, it's hard to disagree with that, and I think that, say, even at the prototype level, with some analysis work being done on there, say, for durability even, or how it's going to survive actually functioning in a vehicle, making sure that high voltage is not going to be shaken or rubbed or exposed then for whatever reason through use. Being able to simulate that early can almost eliminate a step. With our first pass, we're coming to our customers with a product that meets their requirements better than it did before 5 years ago, say.
Okay, and maybe for a moment, let's separate simulation. So let's ask the question for Sean first, and then we go to Michael for more simulation. Sean, if you had to list 1, 2, maybe 3 areas where you feel customers that looking for a battery oftentimes either forget about or don't pay enough attention to or give enough credit as it relates to how big of a challenge it might be, what would these things be? What would these areas be? Is it thermal management, as we talked a little bit about? Is it I don't know, the crash worthiness? Is it the weight, the cooling system, the complete system? What are some of the things that you feel in your experience oftentimes you wish customers would get maybe a higher appreciation for than what you feel right now is, generally speaking, not for each individual customer, but generally speaking?
Well, I'd like to say that all of our customers think of everything before they come to the table. But obviously, there are some things that get overlooked. I think that the amount of detail that needs to happen in the thermal management system, as you mentioned, is something that may not always get its due diligence, and some of the surprises that can happen then are they can at worst case be catastrophic, and in other cases then not get the optimum, say, range or performance out of the batteries. Right, the amount of detail that goes into that to say maintain a delta T across the pack, keeping all of the cells at a very close to same temperature, is very difficult, especially when you're getting into the larger packs that we are now. Some of the trucks that are happening are very large packs, multiple tiers, and being able to keep all of those cells within, say, 5 degrees C is very difficult. So there's quite a bit of effort that has to go into that sometimes is overlooked. And then if you're starting from scratch with the BMS, the amount of effort that it takes to develop that software to cover all of the details that are required in a battery pack takes a really good amount of effort. And you have to spend some time there to make sure that it is as good as it can be. It keeps your battery as safe as it can be, your vehicle, and then by nature the passengers as well. So those are two aspects that I would say that require more attention, say, at the beginning than they normally get.
You're bringing up again a good point. Software, even though oftentimes we think of a battery as a physical, as a mechanical, as a chemical thing, just like in most other domains on a modern vehicle, on the ground, in the air, and in space for sure as well, software plays a critical role. And with that, a perfect segue over to Michael, right? Simulation is software at the end of the day. What do you see with your customers when they come to you? What are many of them missing when it comes to simulation? Maybe they envision it's going to be way more powerful than what it really is, or what simulation today is capable. Is it the exact opposite? They think what it can do is only a fraction of what we can do, right? I always look at, for example, Excel spreadsheet, right? I probably use 1% of the capability that thing has, and I don't recognize how much more it does, because it does for me what it needs. Is that similar in simulation with your tools, or is it a customer the exact opposite? They want more. They feel like it should be able to do more than what it already does.
Yeah, I would say it's sort of mixed, and I would say customers are always pushing the envelope for the development side to create more and more capability. So a lot of them, a big fixation is on battery aging, and this is something that is a very deep area of development within AVL in order to better capture that phenomenon and prescribe actually the causes of the aging, and then ideally customers want to tie that back to use case, and on the BMS side to attempt to mitigate those phenomenon. I think as far as what customers I think are missing when they go straight into the development of a pack and really don't appreciate or I guess utilize the full capability out of simulation is the aging side of things. It's a very complex phenomenon. It needs some testing data that's very tedious to get. It's not a difficult test, it's just a test that takes a long time because aging takes time, and we're only working the real world here, so every second passes is a real second. But at the end of something like that, if they put in that upfront work and get these data and work to understand what's occurring, then in simulation you can run thousands of these type of scenarios in a fraction of the time it would take. And that leads, I think, to a good point that Sean was making on the BMS side, on the software side. You would then be able to develop more robust software to control the battery and understand really how the battery is behaving and what to look out for, and really control it in a more optimum fashion. And I think that quite frankly is the key differentiator among the different battery electric vehicles. Everybody does the teardown, everybody knows what cell everyone is using, everyone knows how the thermal management loop looks, what fluids, what pumps. What people don't have really insight to is in the software, the control strategy, which simulation will allow you to develop more robust solution.
Very good. And quickly, maybe before we wrap it up, Michael, you first. How much does, if any, the simulation tools we're using today need to change when we really get into, as we're doing now, solid-state batteries? Is there a change we need to do? Is there an additional feature or function, new models? Give us a little bit of an idea of what does this transition over to solid-state batteries mean for the tools that we currently use today to develop batteries, or simulate batteries?
I think for the solid-state battery, there's a fragile, I guess, component to it where you can damage the battery by having it exposed to too much NVH. So I think there would have to be a combination of electrochemical phenomenon within this model, as well as NVH sort of durability analysis or perspective on what loads the battery is actually exposed to, the cell specifically. And so I think that is an area where there's still a lot of meat on the bone per se, because these experts in NVH are definitely not chemistry experts, and chemistry experts are definitely not mechanical fatigue experts. So this is the area I think that would have to be sort of united.
Okay. And Sean, similar question, working with liquid-based, then now going to solid-state batteries. What do you see some of the challenges there that are new?
Well, the goal is to achieve energy density, right? So that you can get the same range out of a smaller space in the vehicle, or increased range out of the same space in the vehicle, and being able to package those in a tighter space and with more energy can create issues for thermal propagation, like we started off talking about. Thermal propagation and thermal events is high on every customer's list, and being able to mitigate or eliminate that is going to be key. And being able to simulate the energy that is within those solid state cells, and if something were to go wrong, being able to accurately predict that and analyze it is going to be key. And I think that the AVL tools that Michael uses is an outstanding example of being able to do that.
Okay. And last question for both of you. People that want to become more familiar with, again, in this case, battery development, battery technology, simulation, they listen to podcasts like this. Where do you, Sean, and then Michael afterwards, but Sean, what do you do to keep up with the latest and greatest battery technologies, battery development technologies, as it maybe relates to simulation, as it maybe relates to BMS software, thermal runaway? Is it you read magazines, you go to training courses, you attend conferences, all of the above, none of it? What do you specifically do?
Absolutely, all of the above. I mean, conferences are a great place to be able to see what is up and coming. A lot of customers and a lot of vendors are there too. So we can all be talking on the same topics and on the same level. A lot of people that are on the cutting edge of technology keep their secrets pretty close to their chest. So you've got to have good relationships with those folks. And with AVL's broad depth of both sides of that, customers and vendors, we're able to keep a pulse on what's happening in the industry, whether it be new solid-state cells or immersed cooling, whatever it might be. We're able to stay at the forefront of that, and includes research as well, as you pointed out.
Okay. Michael, what about for you on the simulation side? I assume it's conferences as well. Is it benchmarking or using other people's tools to get more familiar, or talking more customers, or talking to people like Sean internally, right, to figure out, hey, where can we do better, where are things going? But shed a little bit of light on as it relates from your perspective, where you get industry updates, where you keep on the cutting edge.
Yeah. So, I mean, I reference a lot of literature. I read research papers. We stay in touch with what's going on in academia. So it's frequent meetings with the academia in this area. And as Sean had said, it's an area, it's very secretive. But as well, there's a lot of hype within the industry too. So you got to kind of filter out the noise, and also for the secrecy side, you got to connect the dots. So sometimes people allude to things in meetings or speak in sort of a code. You have to be knowledgeable enough to connect the dots of what they're saying to understand what direction they are actually headed. And I think that's a strong skill set that we have at AVL to be able to do that and help the customers while maintaining strict confidentiality with them for the work we do. So yeah, it's all of the above, really, just taking all the information and going to conferences, reading research papers, and maintaining industry connections.
Very good. So again, we never stop learning. We just keep on learning day in and day out, right? The university days or college days or high school days are never over. You continue to work. So very good. Thanks, Michael. Thanks, Sean, for your time, and thanks everybody for tuning in. Thank you.
Thanks for listening to Reimagine Mobility Podcast. If you like this episode, please subscribe and tell a friend.